Hello everyone and welcome back to another video. Today we'll be taking a look at question 3 taken from the 2010 paper. So let's have a quick look at the question. It's from the British Informatics Olympiad as well. So the question basically states that we have jugs of different sizes and we want to transfer with 3 different operations which we can perform, and we want to end up with a certain volume of fluid in one of the jugs. I'll let you have a detailed read of the question and then we'll move on to the solution onto the whiteboard. Okay, so now let's jump to the whiteboard. Pretty much we have 3 different operations which we can perform on the jugs, 1, 2 and 3. Okay, operation 1, let's say, is filling up any of the jugs. Operation 2 is emptying any of the jugs, and operation 3 is transferring fluid from one jug to another. Okay. Now, if you notice, there are many different ways which we can carry out each of these operations, but we'll be coming on to that in more detail in subsequently. So we pretty much start with jug 1 having 0 fluid, and jug 2 having 0 fluid as well. And now, if you're not familiar with breadth first search, or BFS for short, I'd highly recommend watching a video on that first before coming back to this video, since our solution will be involving a BFS solution. So let's have a look at all the possible different operations which we can perform on these 2 jugs. So we could either fill up jug 1, we'll call that case 1, where jug 1 ends up with 3 and jug 2 remains at 0, or case 2, we can fill up jug 2. So in that case, jug 1 will remain empty, and jug 2 will have 5 ounces of fluid. Okay. There aren't any other operations which we can do, since if you notice operation 2, emptying one of the jugs, those jugs are already empty, hence that won't have any effect. And operation 3, which is transferring fluid from one jug to another, those jugs are again empty, hence that has no effect either. Now, for each of these 2 cases, we can perform a variety of different operations. So for example, let's say we have 3 and 0. We could, in that case, choose to fill up jug 2. That will leave us with 3 and 5. We could also transfer fluid from the first jug to the second one. That will be 0 and 3. And I believe that is all the operations which we can do for this particular one. For 0 and 5, we can fill up jug 1, and that will leave us with 3 and 5. Or we can transfer from jug 2 to jug 1, which will leave us with 3 and 2. But this is because the maximum capacity of jug 1 is 3, hence we can't go any further below 3, any more beyond 3, sorry. Hence we'll only transfer 3. Okay? So these were all the next ones which we can do. And now, I'm sure you get the idea, but just for clarity, after this 3 and 5, we can choose to empty. And also, another thing which we can do in both these cases is empty the jugs, in which case we'll end up with empty jugs. However, that's what we started with, so that's a bit pointless anyway. So I'll just rub that out. But from the 3 and 5 case, we can either empty jug 1, empty jug 2, or we can do many other different things. So that would be 3 and 0, sorry. And now for these, we'll have all the possible combinations. For these, we'll also have them. These will also have them. And now, if you're familiar with breadth first search, this is basically turning out to be some sort of BFS tree, since we start off from layer 1, and then we have all these possible different things for layer 2, which is only 2 cases. With layer 3 we have 4, and layer 4, this would just increase exponentially. Now obviously there will be some repeats, so for example 0, 5 we've already encountered here, so hence there's no point carrying on any further over here, okay, since we're already exploring it down this branch, okay. So now now we'll basically just explore how we reach the final state. So if we imagine that we continue operating through each of the possible different states which any of these nodes can end up in. However, if we have a repeat, let's say 0, 5, which we've already explored over here, we don't carry on exploring that branch any further. Okay. Similarly, for 0, 3, we're already exploring. Actually, for 0, 3, we're not exploring an identical one, since 3, 0 is different to 0, 3. Okay. So for 3, 5, again, we're not exploring it. However, both of these are the same, hence we'll have to choose which one we don't explore. 3, 2 is unique, hence we can continue exploring that. And now, if we basically just continue going on further and further and further through all of these branches, eventually we'll end up with our desired combination, which in this case will be sum x and then 4. The problem statement didn't specify any constraints on what the value of the other jug has to be. It just specified that one of the jugs must be 4 at the end of the process. And now we'll also be keeping track of how many previous times an operation has been done on the jug. So for example, in this particular layer, this is layer 2, hence one operation has already been done on all of the jugs in this layer. 2 operations have already been done on all the jugs in this layer. And then for the nth layer, there'll basically be n-1 operations which were done on that particular jug. Okay? Hence, once we finally reach this final arrangement of x and 4, then n-1 will be the total number of operations which will be conducted on this jug, and that will basically be our output message. Since as soon as we find 4 in one of the jugs, we have to break, since we're basically finished whatever the question was asking for. Excuse me. And now let's have a look at the code which I used to solve this problem. So now if we go back to the code, these 3 functions are basically the different ways in, the 3 operations which I was talking about. The emptying the first one, filling up, and transferring. So E and chosen are the 2, E is basically the first one. I can rename this to the first, that might be a bit more intuitive. So this basically transfers, it basically takes the first jug which is there, and it performs operation number 1 on that particular jug. So what this operation 1 is it fills it up. So chosen is the index of the jug which is being chosen, and that's a common naming convention throughout these 3 operations. And in this particular case, we'll just be filling that jug up. On line 5, you may notice that we're taking a deep copy of the particular elements array, and then we're filling it up, so we're changing the value of the elements, and then we're returning the new set of jugs, the new amount of fluid in each jug. Now function 2 is pretty straightforward as well. We basically just empty the chosen jug by setting the value to 0, then we return the elements. Again, we take a deep copy, since if we didn't have this this particular thing, then what would happen is we'd be creating a shallow copy, and then it pretty much wouldn't work, since it doesn't actually create a proper copy. If you want to know more about that, that's a topic for another time, but that's not the subject of this video. And now we have function 3. This is basically the same one. It's the one where you transfer fluid from one jug to another. So what we have is copy creates a copy of E, and what this does is while the capacity of the chosen jug, which is being transferred to, is not reached, we keep on transferring fluid to that jug. Okay. Now chosen 1 is the jug which fluid is being transferred to, and chosen 2 is the jug which fluid is being transferred from. So let's say if we were to transfer all the fluid from jug 2 to jug 1, and jug 2 had 3 ounces and jug 1 had 1 ounce, then we'd basically subtract 2 from jug 2 and add 2 to jug 1, and would end up with 3 in 1. And that's pretty much what this does, and as with the other two functions, we return copy, copy being the final arrangement of the jugs. So now those are the 3 functions. Now the rest of the code will basically be how we conduct our BFS. So we use this data structure called the DQ or DEC inside Python, which is a double-ended queue. This is really handy for doing breadth-first search, since we can basically leverage the pop left functionality. Since we can basically remove elements from the left, since that's how BFS works. We remove the initial elements, and then we append elements to the right, so append them to the end of the queue. That's why we chose a DEC inside this particular code. And now the number is the number of jugs which we have, and required is the required amount of fluid in one of the jugs which we would like. And now numbers are all the different quantities, maximum quantities in each of the jugs which we have. Okay. And now this visited is also quite important, since if you remember when I explained on the whiteboard, I explained that there's no point in revisiting nodes which have already been visited, right? Hence, if we just maintain an array with visited, which has all the particular jog combinations which have already been seen, then we know that if the particular element is already now visited, we don't need to explore that again. Hence, it basically saves some computation time in memory. And now this is basically responsible for appending all possible permutations of the 2 jugs inside our array. Now the reason why we do this is because pretty much if we go back to the whiteboard, we can have various different combinations of the operations. So like, let's say we're transferring jugs, fluid in the jugs, which is operation number 3. And let's say we have 3 jugs, jug 1, 2, 3. We can either transfer from 1 to 2, or we can transfer from 1 to 3, or 2 to 1, or 2 to 3, or 3 to 1, or 3 to 2, which is basically 6 different ways in which we can do this. Hence, if we go back to the code, this permutations array basically just stores all possible ways in which we can transfer between the jugs. And it's also handy for when we're conducting operation 1 and 2, since we can either fill jug 1, 2, or 3, empty jug 1, 2, or 3, and yeah. So that basically is responsible for conducting all possible permutations. And now this operations function, it stores F1, 2, and F3. If you're not familiar with this in Python, I'll explain a bit more in detail once we get to the use of the operations. But for now, this block of code, we iterate through all possible numbers, and we basically just initialize our queue with the initial like a set of values, and these initial sets are each of the jugs filled up. Okay, since regardless of however we formulate our final arrangement, we have to start with filling up one of the jugs at least. Hence, this is our very initial layer 1, if you like, or layer 2, if you remember back to our previous analogy. Okay, and now this is the main part of the code. This is the BFS part of the code. So what we do is, while the length of the queue is greater than 0, i.e. while there are still elements left to be explored, and in this case elements are unique jug configurations, what we do is we basically pop the first element inside the queue from the left. And then what we do after that is we create elements being a tuple, and it's basically the elements 1, 0 deep copy. Okay, so what this does is that each element inside our DEC has 2 important pieces of information which it has. The first one is the jug quantities in each jug, and the second one is the number of operations which it took to get to that particular configuration. So for example, let's say 3 and 5, it will take 2 operations to get to 3 and 5. Since you need to fill jug 3 and then jug 5, or the other way around, but either way, 2 operations. Hence, what that particular element would look like inside our array would be the first element inside that tuple would be 3 and 5, since those are the 2 values in each of the jugs. And the second one would be the number of operations taken to reach that particular configuration. So it would be 2 in this case. Okay? Now the reason why this is important is because when we append elements to the queue later on, we will be incrementing the number of operations. So more on that in a second. So if the element is not in the visited array, remember visited is the set of values which have already been seen. If it's not in the visited array, then we will append it to the visited array, since we don't want to revisit the element in the future. And if the required value is inside the element. Okay, so the required, if you remember, is back to our the required quantity in one of the jugs. If the required is in either one of the jugs, elements, remember elements is the tuple containing the value of both jugs, then we basically print num being the number of operations, as the question asked, and then we break. This is the final bit, which we, this is the final case, after we've completed our entire breadth first search. And now, here's what we do if we haven't reached out in that case. So for each of the function in operations, f1, f2, f3, we create a copy of the elements. If the function is f3, then what we do is, f3 is a bit special since it involves 2 jugs, not just one. So we'll have a look at that a bit later. First we'll look at if the function is f1 or f2 first, since they're a bit simpler. So for each of the possible numbers, we basically, what we basically do is we perform one of the functions, f1 or f2, on the jugs, and we perform a copy being the result from this function which we're currently operating on. And then if the copy is not been visited, i.e. if it's a unique configuration, then we append that to the visited array, as well as incrementing the number of operations by 1. Now this is very important. The reason why we do this is because, remember, if you remember back to our whiteboard when we iterated through each layer, for each subsequent layer, the number of operations increases by 1. So, which is why we increment the number of operations by 1 before adding it back to our queue. And now let's have a quick look at if the function is f3. So, as discussed earlier, the permutations array has all the possible 2 jug permutations, since that's what f3 requires. We basically perform f3 on this, and other gives the array output. Then, very similar to this one, take a deep copy of other, and then we append it to the queue array, and increment the number of operations by 1. And that's pretty much it for our code. And we'll continue to do this until the length of the queue is either 0, in which case we've basically iterated through each possible combination, or we've found our required elements. And that's pretty much it. So now let's test our program on some of the sample test cases. So let's just sorry, this question won't show here. Let's just go over here. It basically gives us 2 HQ, right? Oh, sorry. There we go. It gives us 20 as the output. And now if we go back to the mark scheme, 20 is indeed correct. And now let's just test it on the final one maybe. Our program should give us 40. it's taking a bit of time. Maybe we'll just give it another test case instead. Unfortunately, this code is a bit slow for working with the large test cases, but if you were to write this code inside the actual thing, you'd most likely get almost all the marks. The final ones will be missed, but I think that's more an issue with Python than the logic of the code. So, yes, that is pretty much it for today's video. I really hope you enjoyed, and hopefully you learned something new about maybe BFS or the way English conducted this question. It was a really nice question, and I hope to see you in another video next time. Thank you very much for watching. Bye.